All right, this is the no calculator final review we're going to go through right now, and we'll go through it fairly quickly, but you can pause as needed. So here we go. This is no calculators, keep in mind. It says, what is the quotient remainder of that cubic divided by the first degree binomial? So we're going to do long division here. Now we're not doing synthetic because we would have to doctor this up. We have a 3x plus 1 as opposed to something of the form x minus, say, r, dividing into this polynomial. So we're going to go ahead and do long division. So long division will always work here. Synthetic division, we only use it when we have a coefficient of 1 in front of the x there. So we have 3x cubed minus 5x squared plus 4x plus 1. And let's go ahead and divide. We're going to divide the first term into the first term here. 3x goes into 3x cubed, x squared times, and write x squared down, multiply, distribute. 3x cubed plus x squared. What I like to do is put parentheses around this and a minus sign to tell me I'm distributing that minus sign. So negative 5x squared minus x squared is negative 6x squared. Bring down the 4x. Now divide 3x right here into this one, negative 6x squared. Goes negative 2x times. Distribute that. It's negative 6x squared minus 2x. Parentheses around it. Subtract. 4x minus a negative 2x is 6x. Bring down the 1. 3x into 6x goes 2 times. That's 6x plus 2. Subtract those. You'll see that 1 minus 2 gives me a remainder of negative 1. So I'm going to write this as minus 1 over the divisor 3x plus 1. So that's x squared minus 2x plus 2 minus 1 over 3x plus 1. 3x plus 1 is not a factor of that polynomial there. You can see that because I don't get a remainder of 0. All right, the next one on there, we're going to just apply the formula. So you'll have the formula on your formula sheet. We're going to go ahead and apply it to simplify this. So I've got cosine of x, cosine 3 pi over 2, minus sine of x, sine 3 pi over 2. Replace the ones that have radian measures for the angles in there. Cosine of x times 0 minus sine of x. Sine of 3 pi over 2 is negative 1. This whole term is gone. Negative negative is positive sine of x, and that is the simplified version for number 2. All right, moving on. Number 3. It says, what is the amplitude and period of the following function? Amplitude is the absolute value of negative 3 is our amp. That is 3. So 3 is our amplitude. Period can be found by taking this value, which is b, and plugging it into the relationship period equals 2 pi over b. So 2 pi over 6 gives me pi over 3 is the period. All right, number 4. It says, find the exact value of this expression. Well, think of this as ln of e to the 1/3 power. Maybe first, that cubed root of e is the same as e to the 1/3 power. Bring the 1/3 out in front. That's one of the properties of logarithms. Another property of logarithms says that ln of e is 1. Think of this as log base e of e equals x. That would be e to what power equals e, and x would have to equal 1 for those to match here and here. So ln of e is 1. Hopefully that'll help you remember it. But think of this as ln of e is the same as log base e of e. Set that equal to x. Use your definition. E to what power equals e to the first. X would have to equal 1. So ln of e is 1. So this equals 1/3. All right, this one, we are going to join these together as a single logarithm. First thing we're going to do is move these guys up here. Do that first. Log x to the 3rd minus log x minus 1 to the 6th. We're doing the reverse operation of what we just did on the previous problem. We moved that 1/3 down as a factor. Here we're moving the factors up as powers. When you're subtracting two logs, it's the same as a single logarithm of the quotient of the two. All right, number 6, we're changing this from polar to rectangular. So it says find the rectangular coordinates of this thing. So I would just say, okay, x is going to equal 7 cosine 5 pi over 6, and y is going to equal 7 sine 5 pi over 6. So this is 7 times cosine of 5 power 6 is root 3 over 2. Actually, negative root 3 over 2. Quick picture. This would be somewhere over here. And then sine would be 7, sine of 5 pi over 6 would be 1/2. So it equals 7/2. So I get, in rectangular form, this would be negative 7 root 3 over 2, comma, 7 over 2. That's number 6. All right, next one's here. 7, number 7, we have tangent theta equals 1 over square root of 143. Let's draw a picture here. Here we are, first quadrant, here's theta. That's saying the opposite is 1, and the adjacent is square root of 143, obviously not to scale here. Square root of 143, opposite is 1. We would use the Pythagorean theorem. 1 squared plus square root of 143 squared, take the square root of that thing. That's 1 plus 143 is 144. Square root of 144 is 12, so that's 12. So it says find the values of sine theta and cosine theta. So we are in the first quadrant. Cosine theta is adjacent, square root of 143, over hypotenuse, 12, and sine of theta is going to be equal to opposite, 1 over hypotenuse, 12. Okay, this one, work from the inside out. We're down here, sine of 4 pi over 3. So that's inverse sine of 4 pi over 3 would give me a negative root 3 over 2. Now, inverse sine does have a specific functional output for the range, and that needs to be down over here. It's got to be in one of these two quadrants between negative pi over 2 and pi over 2. So whereas the arc whose sine is negative root 3 over 2 in either this quadrant or this quadrant, it's got to be down here. So that angle is farther down than it is out. Angle negative pi over 3. Alright, number 9, 288. We're going to convert it to radians. Quick conversion here. Oops. So we have 288. We're going to multiply it by something. So it's 288 degrees is equal to, change this to radians. So we're going to multiply it by pi over 180. If we're in radians, we multiply by 180 over pi to change it to degrees. So here we are in degrees. We're going to change it to radians, multiply by pi over 180. So 288 pi over 180. Go ahead and simplify that. That's going to simplify all the way down to 8 pi over 5. So that should work on that simplification there. Number 10. We are asked in number 10 to find the center and 4 vertices for the ellipse. So first thing I'm going to do is divide through by 64. Set this equal to 1. That's our standard form for this. So x squared over 4 goes into 64 16 times. 16 goes into 64 4 times. Goes 1. So we have, if I were to draw a picture here, an ellipse centered at 0, 0. Notice there's nothing paired with x and y. We're going to go 1, 2, 3, 4 in the x direction, 2 in the y direction, and draw our ellipse. So we've got vertices here at 4, 0. That's a vertex. We'll call it V1. Another one here, vertex at negative 4, 0. And then we have co-vertices here at 0, 2. We'll call it co-vertex 1, and 0, negative 2. Co-vertex 2. All right, number 11 says given A is equal to that and B is equal to that, we're going to find A times B in polar form. So A times B is equal to the product of 6 times 4 times, I'm going to use our notation, our shorthand. It's cis, which stands for cosine of an angle, plus I sine of an angle, so cis. And what we're going to do with these is add the two angles. If I'm asked to divide, I will subtract the two angles and divide the coefficients of each of these. So this is 24 cis, change pi over 3 to 12 by multiplying by 3 over 3. 3 over, how about 4 over 4? So 4 pi over 12 plus pi over 12 gives us 5 pi over 12. So box our answer here. 5 That's the product of the two. Let's go ahead and find quotient of the two. So A divided by B will be 6 over 4 cis pi over 3 minus pi over 12. Once again, that was 3 halves cis. This was a 4 pi over 12 minus pi over 12, which is 3 pi over 12, also known as pi over 4. And we'll leave it in that form. It says leave it in polar form. All right, on to the back side here. This is evaluate 2 plus 2i to the 6th expressed in rectangular form. We're going to use De Morvay's theorem. It's the last formula on your formula sheet. So here we go. The formula says take and find r. So r is equal to square root of 2 squared plus 2 squared. 4 plus 4 is 8. Square root of 8 simplifies to 2 root 2. So this thing's going to be equal to 2 root 2 to the 6th. And we're going to use our shorthand again here. Cis of, okay, let's draw a picture. We got to find the angle theta. Angle theta, it's 2 out, 2 up. So we are right at a 45 here. 2 out, 2 up. There's theta. That's a 45. 45 right triangle. So we got theta equals pi over 4. If you don't see that, you can do inverse tangent of 2 over 2 or inverse tangent of 1. And we should know the arc whose tangent of 1 is pi over 4. That's pi over 4 to the 6th power. So we're going to put that in the 6th power. Now, what De Morvay's theorem says is you can go ahead and bring that power in and multiply it by the argument. So this is equal to 2 root 2 to the 6th is going to give us 2 to the 6th times root 2 to the 6th, which is the same as 2 to the 6th times 2 to the 3rd, which is 512. And we've got cis, cosine plus I sine, of 6 times pi over 4, better known as 3 pi over 2. So 512 cis 3 pi over 2. If we're going to write that in rectangular form, it might help see this as 512 cosine of 3 pi over 2 plus I, well, let's put another 512 in there, plus 512 I sine 3 pi over 2. That's taking it from that shorthand cis form back to longhand. So 512 cosine of 3 pi over 2, that's a 0, so that's completely gone. Sine of 3 pi over 2 is negative 1, so this ends up being 512 I times negative 1, also known as negative 512 I. There it is. The next one, find the absolute value of the complex number. Let's just draw a picture of this. It's 2 left, 5 down, just like a vector here. And so we're just trying to find, really, the length of the hypotenuse of that right triangle we just formed. It's 2, that's 5, so 2 squared plus 5 squared equals square root of that. 25 plus 4, square root of 29, and we're done. All right, 14. Write a cosine equation to match. So we're going to go y equals, or you could do f of x equals. Through the middle here, it looks like we're 2 down. I had to kind of look at that carefully, but 2 down. Maybe 1, 2, 3, 4. 1, 2, 3, 4. I'm not sure. Might be a little more than 2 down here. Let's see. 1, 2, 3, 4, 5. No, it should be about 2 down. So 1, 2, 3, 4, 5. Okay, I didn't count right. 5 in each direction. So this is the line y equals negative 2. That's my new midline. So you can see that the amplitude is 5. Now, if I'm going to do a cosine function, I'm going to have to decide where I'm going to start this guy out at. It's kind of your choice. I chose to start it right here, go through a cycle to here. And so I'm going 1, 2, 3, 4, 5, 6, 7, 8. So my period is 8. That. I'm shifting over -1, so that'll play into my phase shift. I'm shifting down -2 units. So I think I have everything there. So amplitude, let's just write all that down. Amp seems to be 5. Period is equal to, oh, this is measuring by pi. I missed that. So there's a little pi right there. 8 pi. So period is 8 pi. Phase shift is equal to -1. Vertical shift is equal to negative 2. So I think I have everything I need. Now if the period is 8 pi, that's not what's going to go in here for b, but I have 5 cosine. I have something here for b. I'll put it right in here. And then I have a phase shift of 1, so this will be x minus a negative 1 or x plus 1, and then a vertical shift of minus 2. You need to find what goes in that circle there. So remember, period, 8 pi equals 2 pi over b. Swap these two, so we get 2 pi over 8 pi will equal my b, and so 2 pi over 8 pi simplifies to 1/4. Should be a 1/4 there. Make that readable. 1/4 right here, and that's the cosine function. Now there are other answers to this. It depends on what your phase shift is going to be. That period and amplitude and vertical shift should all remain the same. If you want to, I think in the answer here I might have distributed that 1/4 x. Oops, I goofed on this too. Let's see. Oh, that's right. This is not a 1, not a 1, so let's fix that. Sorry about that. We're counting by pi's. I missed that. So instead of a phase shift of negative 1 up here, I actually have a phase shift of negative pi. This is negative 2 still, so that is x minus pi, which becomes x minus negative pi, which is x plus pi. So that's plus 1/4 pi and minus 2. So sorry, this was counting once again by pi's, not 1's. So there it is. Number 15, we're asked to graph this thing. So number 15, we have to first get it in standard form. You can see because of the minus sign, this is going to be a hyperbola. So y squared over 4 minus x squared over 25 equals 1. This is going to open in the y direction because this is positive. Take the square root of that bottom portion of the fraction. Square root of 4 is 2, plus or minus 2, so we're going to go 2 in each direction. Center is 0, 0. We're going to go 5 in each direction in the x. Draw our little hyperbola box. Put a dashed line through here. And they're going to open up in each direction here. So that is a sketch of the picture of the graph of 25y squared minus 4x squared equals 100. Number 16. Oh, matrix multiplication. Now, process here. Zoom. Row times column. So it looks like this. We've got a 3 by 3. It's helpful to think about dimensions. 3 by 2, that's going to equal a 3 by 2. We get that from the outer 2 here. So following that pattern there, first row times first column. Got my 3 by 2. So 3 rows, 2 columns. I'll make that bigger to start with here. So we have 5 times 9 plus negative 4 times 0 plus 2 times 3. It's going to have to be even bigger than this. It's kind of open here and here. Let's leave that open for now. Move this back up over here. All right, the next one is going to be this row times the next column. So we have 5 times negative 2 plus negative 4 times 6 plus 2 times negative 1. The next row, we're going to do the next row times the first column and times the second column. So we're going to go second row times this. So it's 1 times 9 plus 0 times 0. Notice what's in parentheses is matching up here. 3 times 3. That's 3 right there. And then we're going to go and do the next one. So it'll be 1 times negative 2 plus 0 times 6 plus 3 times negative 1. And we'll go do the last row in each of those columns. So we got 7 times 9 plus 11 times 0 plus negative 1 times 3. And then the next one is 7 times negative 2 plus 11 times 6 plus negative 1 times negative 1. And when you multiply those together, okay, so multiply those together. Top one ends up being 51 and negative 36. Second row is 18 negative 5. Third row is 63. That's our 3 by 2 matrix. All right, so going on to the next one here. I've given you the inverse. I have not shown you how to calculate the inverse, calculate it on the calculator. But let's go ahead and multiply that inverse times the answer column here. So it's going to be 1, 2, negative 1, 0, 1, negative 1, negative 1, 0, 2 times 3, negative 5, 2. That's our equation C inverse times B, if you will, to give us x, y, and z. So multiplying those down, we're going to get 1 times 3 plus 2 times negative 5 plus negative 1 times 2. And then we've got 0 times 3 plus 1 times negative 5 plus negative 1 times 2. And then we've got negative 1 times 3 plus 0 times negative 5 plus 2 times 2. So 3 negative minus 2, negative 7, minus 2 more, negative 9. So it should be negative 9, so negative 9 is our x. So minus 5, minus 7 is our y, and then negative 3. I think I might have missed a sign here. Let's see, 2 times negative 2. Okay, we had a negative 2 down here. Negative 2, that means that's a negative 2 right there. So just note that. So negative 3, negative 4 is negative 7. So that's our x, y, and z. Negative 9, negative 7, negative 7. All right. One more here. Actually, that's it. Number 17 is it. So yeah, make sure you get this right here. If I'd done it in black, I would have circled that in red. Put a minus 2 on it or something for you. But that's a negative 2 right there. I did not copy down that negative sign correctly there. So negative 9, negative 7 is the correct solution.